So this is one of the worst kind of technical journalism I can see online and make me make an article about it. So the article, first of all, is clickbaity, saying Python is 71 times slower using 75 times more energy than C. But this is not quite what the source says, and this is quite important, and we will go there. But what the paper tries to achieve or to measure is that how to make your programs energy efficient, and it gives a methodology how even the RAM consumption would increase the power usage, which many people don't take it into account. And based on that, you can get C being basically, at least in some programs, which will go to which ones, you'll get big speedups. But these programs, to be very clear, they are more or less compute kernels. They are what is named computer language benchmark or Debian alias computer benchmark. And it's a set of tests and people write it in very many languages. And why is important first is that if your conclusion when you read this paper should be is that if you have some very compute kernels, you may need to write them in whatever languages are recommended to save power. That's the single conclusion if you take the paper without any criticism of its value. But the author here, the Brian, says that you have no excuse but to write to save power at least in C, and this is silly. So if you have your requirement, let me save as much power as I can. There are many ways you can save powers, and I will not want to make a full course on how to save power. But in general, if your program, for example, scales easier with more cores, and to write it in C it will take too long, just using 4 cores but working, let's say, twice as slow per core, but twice as fast because you use 4 cores, you'll in fact save power because how CPUs they do right now boost, the race to sleep is what saves you power. And this is the scratching the surface. The other part is that if you have an application with many users and you want to save power, probably you'll focus to run on mobile only because mobiles use much less power than the desktops. So just run it on mobile and you'll write it probably in Java or Swift and you'll get the high level performance. And this is the first part which is wrong. The other part, and this is more important, is that when you look on this diagram, you'll miss that this was normalized for some tests. So, and here you may see some notes like some values are per whatever tests and so on. So which are these tests? And if you look on the top, they are described which ones are these ones. And body, fast, no. And the biggest analysis is on the first 3 alphabetical chosen, so binary trees, and I forgot all the others. So this is all the paper is about. And if you look also specifically, let's say, for the sake of argument, let's take that your company has a lot of n-body simulations. I don't know why you care how the planets run. Would you write everything in C? It depends. I would not write firstly in C if I want to need it as a web service. Probably a Java-like implementation. It's easier to write it in a Java-like environment. And it's easier to find developers with Java to give you a fast web interface than to write it with C. I'm not saying Apache, you can't write web services with Apache or Nginx or other types of CGI, but realistically, Java may be a better solution for that part, and we'll talk even Python. And I ran I use very likely the same methodology but on Windows because we can understand that are not always the same runtimes. So if you run it with CLion, this particular test, n-body, so n-body rotates planets, and I increased the limit by around 5 times, and I will say to you why. It's because Java needs a starting up time. Here I'm getting 9.2 seconds, but in fact this is a bad time because I am recording. So I created, spoiler alert, it runs more or less the best times around 8.6 seconds, especially if you cool it down. And let's take this a factor of 1. And many people don't know, but Java has multiple implementations. So most people use Java from Oracle or from Zulu, but you have OpenGen9, which may run even a bit worse. So the ratio is, no, it runs a bit better. 1.44 ratio versus 1.62. But there is a Java named GraalVM, which is just 21% slower than the C runtime. And it will be a bit better, the ratio for C, so the slowdown will be bigger if the iteration is a bit smaller, because the Java takes around a third of a second initially um, to start up, to compile enough methods. So when this is not a factor, this is a much better ratio than the table in the paper. So let's go back to the table in the paper, which we were doing before. And not here, it's here. Okay, so Java in general as runtime speed, it was 1.89 times slower. But this matters also the numbers of iterations. But if you always run NBody, it will go maybe on the same range with C++, at least in the same implementations from NBody. And this is not that thing. So this 50% is for regular Java, and it will be somewhere in the middle, 1.25, something like that. It will be a Java running on GraalVM, which is the speediest implementation of Java. But obviously the paper doesn't take into account this part, because that was not the point of the paper. It was to check with the defaults, with the person basically not knowing what power saving is, that you can save some power. And on the similar note, let's go with Python. So the Python, which was in the paper, it was saying that it uses 75 times more energy and it runs 71, almost 72 times slower. But I can show it to you that my Python doesn't run so slow. So it will take some time, just to be very clear. But it will not take that much time. So, okay, it will take something, but it will not take 5 minutes or something like that, like it was in the test. And I say, what did I do so wrong or something like that? And most people who know how to compute these things will say, yes, of course, to use that. And we will go back, so it's 33 seconds. So 33 seconds, it is a slowdown, I don't know, a factor of 3, sorry, 3, a factor of 15. So this program would run 15 times slower than the original benchmarks. But here it says 71. So what happens is that obviously there is another implementation of Python, and this is quite known to be used for compute kind of implementation, and this is PyPy. PyPy is not always fully compatible with Python, but it's close enough, and especially if you know that this is your challenge, you have to do it. This is a standard way to do it, and obviously there are more solutions, and I will not talk about Mojo, which some people will say is not Python, but just to say that because one benchmark says this, you should have to take it for granted. This is quite silly. And to me, what I'm the most upset is not the exact numbers or energy or something like that. Is that even in the same paper you can see that same issue. So for example, Ruby, it has a factor of slowdown of energy like 70 times slower and the slowdown of 59. But it also says JRuby, which is just another implementation of Ruby, which is 40 times slower than the best C implementation. And obviously PyPy works nicer here. It's a factor of 15. It's like between Hack and Ratchet on my machine, at least. And it's just that the paper doesn't go there, but you can extrapolate their own conclusions. It's like if you have no clue and you just put microkernels, sure. And the last part which I want to say, as I was saying before earlier, it depends where you put the Python. Dropbox is known to have, at least in the past, I don't know right now, Python as their plugin of shell and so on, and it was doing a lot of calls back and forth, so it has an embedded Python, and most people don't notice it, that it is slow because it's Python, even it's 70 times slower, because Python is not using the hot code. The hot code is written in Rust, the second in the list here, and that solves it. And on a similar note, you have to be smart when you do whatever. So if you have a server with a Django, let's say, the database will be written in C, so this will be high performance. Your stack of HTTPS probably will be some OpenSSL that's written in C, so you're solved. Probably you work with a module, let's say in Apache or something like that. They may use do compression and so on, written in C, and you'll not use Python, but for some business logic and wiring, and that's fast. I mean, it's not as fast as C, to be very clear. So that 70 times, 75 times slowdown is never happening. It will be probably kind of 3 times slowdown in a real application, because you'll not put Python in your hottest of the loop, or you shouldn't at least. And this is what I think Brian seems to miss. So the page was very specific for some algorithms, which you put them one-to-one, doesn't take into account anything like, can you do green threads? Can you run it without any interpreter lock like JRuby? There is no Jython implementation. I didn't try Jython. I'm very happy with PyPy, which I'm just saying it worked fantastically here. But let's not make too sensationalistic news when there are none. Or it is very interesting paper to read. It has a lot of data, but don't extrapolate just because you like too much the C language. Thank you, and bye bye.